So, with that said, let's bring out the last company. And coming all the way from the Netherlands, we have Incooling. Presenting for Incooling is Helena Somodeva, co-founder and CEO, and Rudy Verwey. Come on out.
In the last 2 years, we have created more data than the entire history of humankind. Now, our friend Gordon Moore correctly predicted that every 2 years, our computing capacity will double. It became smaller, faster, and more efficient over time. It was working until today, because today we are at a turning point. For the first time ever, our demand for data is bigger than what technology can handle. And it's not that technology is not there. It is, but we have a new issue: the heat. You see, the more you ask your computer to do stuff, it overheats. And as it overheats, it becomes slower. Every time during pandemic you had a Zoom or Microsoft call and it dropped, it's because a server somewhere in a data center simply overheated. Now, data centers have cooling solutions, but this heat is a new problem. And the solutions today are archaic and simply just not good enough. There is a solution: Incooling. Our mission is to cool down the planet one server at a time. Now, the way we started was by partnering with the largest scientific experiment on the planet, the Large Hadron Collider located in Switzerland. Now, as a particle accelerator, they have these sensors inside the experiment itself, and they track the activity of the particles, and they needed cooling. It was quite interesting because it's located 60 meters under the ground, there's radiation, it's vacuum, and very, very high heat. And they themselves struggled with cooling, so they had to design their own two-phase cooling system. Now, what is two-phase? Two-phase simply means it's going from liquid state to gas state, simply like your kettle when you're making your tea, so it does the same here. The difference from air cooling or water cooling that's used today, this can allow us to go below ambient. That means we can go below room temperature, and that is no cooling system in the market can do that today. Essentially, what they built and what we're building is a fridge on the CPU. Now, by partnering with them, we realized there is a need in the data center industry, so we took the same approach and developed our own two-phase cooling system. And with our partners, we integrated it in our own Incooling server. Now, what does the server look like? Let's look to the demo. So, this is my team streaming live from Eindhoven in the Netherlands in a high-tech campus. As you can see, it's middle of the night there. They specifically came in to run the test, and show you how it works. So this is our server. It's a standard server. You can insert it in any data center today, so you don't have to change a thing. And inside is our magic cooling system. What we can do with this server is run a number of tests. So right now they're running a test. It's called Cinebench. It's modeling a 3D animation, how fast you can do it. So it works in engineering, movie industry, banking, and whatever. So the important thing to look at now here is the CPU temperature that you can see at the top left corner for you guys. It says 13 degrees Celsius. That's around 30 degrees Fahrenheit, I think, in the US. That is lowest temperature you can ever get on the CPU. No system in the world can do that. And why do we need it to go so low? By going lower on the CPU, we both accelerate it, so we make it go faster, and we can actually make it more energy efficient. End of demo. So, we took that server you just saw, we put it in our client's location, we ran a similar test, and with our system, we were able to run their computing task almost 50% less time, whilst using only half of the energy. This is a wow moment. Yes, yes. Now, who needs this? In banking, you want to buy stocks, right? You want to make sure you're the first one. You really need fast servers. You're running innovation. Almost every startup here on the stage today uses computing, and to be able to do that, they need fast compute, so we can accelerate their innovation as well, or anything that uses real-time data and needs reliability. I'm Helena. This is my co-founder, Rudy, and together, we're the co-founders of the company, and we have team members with more than 20 years of experience in semiconductors, as well as serial entrepreneurs. Together, we have around 3 more spots left for pilot projects. We're in pilot stage. So if you want to have the world's fastest and most efficient server to accelerate your innovation, then get in touch with us. And by joining us, you will also join us in our mission to cool down the planet one server at a time. That's Incooling.
Elena, that was wonderful. Thank you so much. Milo, let's start with you.
Oh, you're kicking it. I'm kicking it off?
Yeah, you are.
Oh.
It's your turn.
I love it. It's really cool. Great presentation. My question to you is, there are a number of other technologies, I think, working on cooling servers. And I was wondering if you had done any work to evaluate how you stacked up to those other technologies. And they're not only just in cooling, right? Or they're all in the cooling sector, but some of them are looking at having like a unique metal framework on the back of the chips that, you know, dissipates the heat more efficiently. Could you just maybe like talk a little bit about the competitive landscape?
Yeah, so in the CPU world, there are different CPUs. So different cooling methods are necessary. It's not one size fits all. So we're focusing on high-performance computing, where you have very high heat densities. And with the cooling systems today, Intel and AMD, they focused on creating the best chip ever, but they sort of forgot about the cooling. The cooling industry is not as interesting as the CPU industry. So essentially, they become really hot, and the cooling systems just simply cannot handle it. So we tested with water, we tested with air. There's also immersion cooling, which is a new thing, but it's for a different application. And in fact, if you put a really high-performance thing in an immersion cooling, it actually might set on fire, so you don't want to do that.
Dave?
Yeah, on the chart that you showed with Moore's Law, each one of those dots along the way was, a chip that was designed by hundreds of people, took many, many years to design, tens of millions of dollars. Are you expecting that you will both innovate on chips and performance of chips and this cooling technology? Or is your vision that the cooling technology is the differentiator and you'll plug into standard chips that are produced by other CPU manufacturers?
So our long-term goal, we are a cooling company at heart, and our long-term goal is to cool. So we started off with the idea that the heat is going to be there, the problem is going to remain, and the way to solve it is actually by going in silicon. So we worked with CERN, where the technology came from, and they spent, I think, $1.2 billion on researching phase change cooling in silicon. So they've done that before, but it's only, again, for different applications. So what we want to do eventually is to work with chip manufacturers, with cooling companies, and integrate it into one, and therefore solve the issue of heat once and for all.
So from a commercial perspective, it would make sense that you do deals with each chip manufacturer, and they incorporate you into their chip design?
Yes, eventually. Right now, we're early stage, so right now we're focused on the chip. So we're working with server manufacturers, but eventually we're setting up the roadmap for CPU.
Thanks.
Jameson?
Terrific. Could you talk a little bit more about this sort of initial go-to-market, and in particular, sort of what do you feel like is the time to being in market, and what have the conversations been with sort of early customers around the barriers to getting there?
Yeah, so right now we are at a pilot stage, so we're actually deploying our first servers into the market. A big barrier at the beginning was pre-pandemic, people didn't realize that we needed compute. You had face-to-face, and it was all great, and then pandemic hit, and then data centers went actually above their limits, and they exceeded what they can do. And then they realized, oh, we need better cooling, we need better compute. So that gave us an opportunity. People reached out to us. We partnered with a data center, for example, installer. We partnered up with them to, when they build data centers, have better servers. We actually deployed already one of the servers already. It's been running for a year, no problems. And that's how we're trying to get into the market through the partnerships.
Got it. Makes sense. Thank you.
Charles?
Can you tell me a little bit about just, you talked about performance, but also just sort of price and how this compares to alternatives on a price dimension?
Yeah. It's always very difficult to pinpoint. It depends, right? If another pandemic hits, the stock is gonna go up, and then it might go down. We're working together with AMD, for example, and we've worked with Intel, and we're setting at competitive prices. So evaluating what is performance worth is not easy because it changes day to day, but we're setting it according to what the market requires it today. So we're kind of the top league of the server market today.
Great. Emmeline?
Yeah, I so appreciate it. I maybe picking back a bit on the earlier question. As you think about folks like Liquid Stack and Asperitas and others who are kind of really creating these closed-loop cooling systems within data centers, do you see yourself integrating alongside those types of folks because you're really kind of cooling at the chip level? And if so, just give us a sense of how that kind of go-to-market motion looks as you're selling kind of alongside some of these players and the investments already made.
Yeah. So what is really different with, for example, Asperitas and the Submer, they really require a lot of new infrastructure. We envision every single data center that's currently running on air cooling can put our server in right away. That's our go-to market. That's where really we had to put a lot of time and effort in making it fully self-sustainable. And that is where we make a lot of difference. Later on, we can always integrate also with other parties.
Super helpful. And then maybe just a follow-up, talk a little bit about the BOM. Like, how much does it cost to actually create the server today, with the device and everything?
The server, yeah, it's pretty standard. As we're working with a server manufacturer, so we get all the components off shelf. What we do is we make our own design in terms of, okay, what specifications. So it's not only the cooling itself, but it's also, we select the right memory, we select the right CPU. So right now we're working with AMD, the up and runner in the industry. So what you saw was 64 cores, so it was extremely, extremely fast. The cooling part is the most expensive, so compared to the competition out there, it's much more expensive, but also the result you get is you cannot get it elsewhere. And what was surprising for us is today you can buy a CPU, it costs around $7,000 or euros, and the cooler that comes with it is $30. So there's a big price difference, and of course, and you're not able to use that CPU to its max capacity that it's designed. So you paid for something, and you're not able to use it. And with better cooling, more expensive cooling, in the end, you still get that money back because it's more energy efficient. You made your task on time, and if you're an engineering company and you have 200 people working on this, and you save everybody's time an hour a day, that scales and scales a lot.
Well, thank you very much. Give it up for Incooling.
Thank you.